In this video, I'm going to answer the question, why does the log with an argument raised to the power equal that power multiplied by the log of that argument? And in order to make this work, we need the definition of a logarithm. The fact that logarithms and exponential functions are tied together in a special way, and the inverse concept. So we're going to use that fact, and then we're going to just use a exponential property to help make this all come together. So first thing I'm going to do is just let x equal log base b of m. And by definition, and this is where you have to remember again what the logs mean. Logs give you powers. So the x answer here on the left side is actually representing the power needed for the base b in order to get it to equal m. So by definition, that b raised to the x power will equal m. Okay, and let's go ahead and just jump right into it then, because basically that's all we need, and then one other little exponential property that we'll see in the process here. So let's start out with that left side. I'm wanting to show that this log base b of m raised to the p power is equal to that right side up here. So what I'm going to do first is just take that log base b. I'm going to replace the m with b to the x. Where am I getting that? From that definition-based result. So m is equal to b to the x, and then that will be raised to the p power. So this piece right here, this is crucial. This is where I need to use an exponential property. When you have something raised to a power and then parentheses and then another power outside, you just multiply the two powers together. So you're going to get log base b of b and then raised to the p times x power. You could write that as x times p, doesn't matter, but you'll see why I write it as p times x here shortly. So that's just using the exponential rule. Multiply those powers. And now I am going to find the answer to this log right here. I need the answer to this in order to get to that right side up here that we're aiming for. And remember what logs are. Logs are going to give you powers, and more importantly, they're powers needed to take that base and get it to equal the argument. So in this case, I'm asking myself, what power is needed to get the base b to be equal to b to the p times x power? It should be clear that the power needed to get that base b to equal b to the p times x power is just p times x. The power answer to that log is just p times x. And now I just need to take the fact that x does equal to log base b of m, how I started it out there, and then I get p times log base b of m when I replace that x with what I set it equal to. And then you're done. So that's why when you have a log of an argument raised to a power, it equals that power times the log of the argument. I hope that helped, and thank you for watching.